Sup, broskies? DJ Carrier and the Slam Van are going to educate y'all about the chemistry of storms, lightning, and tornadoes.
Don't call me that.
But in this demo, we're going to elaborate on how lightning comes to be, which is the buildup of electrical charge and the negatively charged ions in the cloud jumping to the positively charged ions in the ground. Here, we have a Tesla coil and a light bulb to show how it works. Whoa, bros, that's pretty radical.
As you can see, the Tesla coil creates an electrical field which provides enough energy to ignite the gas, mercury, inside the bulb and emit light.
Now DJ Carrier is going to show you how it works.
Please stop calling me that. The primary power source,
AKA the battery.
connects to the primary coil.
This tall thing.
The coil can withstand massive amounts of current, which is why copper is used.
I'm currently bored. Can we speed this up?
No, we have to make 15 minutes, remember?
Fine.
The capacitor builds up enough energy to break down the air resistance in the spark gap.
Basically, this thing makes enough energy for energy to jump across.
Then, the current flows out of the capacitor into the primary coil, creating a magnetic field.
A field of power.
This negatively charged field is attracted to the positively charged gas in the bulb and ignites the gas.
Don't you just love all this positive energy and negative energy?
It's science. Of course I love it. The coil represents the thundercloud because it contains the negatively charged ions. The light bulb represents the surface of the ground because it's where the positively charged ions are located. And the flow of electrical current represents lightning because it's the discharge between negative ions and positive ions.
Now you'll know how it works. Here's what you need to make your own. First, you're gonna need some PVC pipe.
Approximately 6 inches long.
Then, just some regular old magnet wire.
Actually, you need 26 gauge magnet wire.
Come on, John, why you gotta be so technical?
So they can do this right.
Whatevs. Now you're gonna need some duct tape and an on and off switch.
Our light switch is not a normal light switch. You have to hold down the button for the current to continue to flow through the circuit.
Then you need some sort of wire.
Insulated wire.
Then you need a 2N222A transistor.
That's actually correct for once.
Then you're gonna need a 29,000 resistor.
In our design, we were able to solder together 3 10K resistors as a substitute because we did not have a 29K resistor.
Then you're gonna need an average everyday golf ball, a 9-volt battery, a 9-volt battery terminal, tin foil, and the most important thing, a bottle cap.
Very good, Sean. You were able to do the very simple task of reading a list.
I'm not done yet. The tools you're gonna need are some wire strippers, scissors, a ruler, hot glue gun, soldering iron, and some solder for the soldering iron.
For those of you who do not know what a soldering iron is, it is a device with a hot metal tip that can reach over 800 degrees Fahrenheit. Very similar to a blowtorch, but without the fire. The solder has a very low boiling point, I guess you would call it, and it melts very easily and becomes metal glue.
Now you'll know what you need. Here's how to build it.
First, you will need the PVC pipe and the 26 gauge magnet wire. Tightly wrap the wire around the pipe approximately 1/4 inch from the top of the pipe. Leave wire exposed on the top and the bottom of the pipe. Then glue.
Oh, whoa, what's up? What's up? I didn't do anything.
Then glue the pipe to the DVD casing. Take the first coil to secure the pipe, or to secure the wire to the pipe. Use a screwdriver or a drill to place 3 holes approximately 1/2 inch apart on the DVD casing. Pick up the on-off switch and trace its shape with a marker. Cut the hole with a box cutter following the traced shape. Once the shape is cut, place the light switch in the hole with the prong disposed underneath the casing. Like that.
Like that.
Take exposed wire endings and put it through the leftmost hole in the casing, the wire from the primary coil.
Yep.
Wrap the insulated wire 3 times around the PVC pipe, inserting its endings into the 2 remaining holes and glue them in place. Also glue the exposed wire ending to make sure they do not move while you're soldering.
Glue is your friend.
Glue the bottle cap immediately beside the switch prongs. Take the transistor, the small 3-prong device, and glue it to the edge of the bottle cap aimed at the center of the casing. You will need to glue the bottle cap right there.
That's why it's so important.
Solder the insulated wire and the resistors, or resistors chain in our case, to one of the prongs on the switch. It doesn't matter which one. Solder the resistor end and the exposed wire together, and then connect them to the middle point on the transistor. Solder the other insulated wire ending to the leftmost transistor point, which is also known as the emitter. Then you will need to take the 9-volt battery terminal and grab the black wire on it, which is the negative ending, and solder it to the last point remaining on the transistor, which is the rightmost point. Solder the positive wire of the 9-volt terminal, which is the red wire, to the second and last light bulb prong. Then the last part, which is the golf ball. Take the golf ball and wrap it in a single layer of tin foil. Take the wire ending from the top of the tower, right there, and glue it to the foil around the golf ball. Then glue the ball to the tower. Once all the hot glue has settled, you can then plug in the 9-volt battery to the terminal and play with the test coil.
Okay, my fellowy fellows, now that y'all now that we went through the long and wordy process of this lab, here's a short video to explain the exact same thing we said, but with elevator music.